Hello everyone. Today we are going to discuss about a new chapter, Introduction to Numpy. Actually, Numpy represents numerical Python and it is actually a library in Python and it comes along with the Python packages. So Numpy, as I have already told you, which is a numerical Python, and we usually make use of this Numpy library to work with data analysis and scientific computing, especially to work with mathematical related functions. We make use of this NumPy library in Python, and it supports the multi-dimensional array object in the sense it supports the array related concepts. It works related to the array related concepts, which means arrays usually store the elements of same data type. But only thing is, the only difference between array and list is which is much similar to list. In list, we will store all the elements of different data types. Elements belong to different data types will be stored in list, but the elements will be stored according to the index position and we will be retrieving based on the index position. Much similar to that, even in NumPy array, we will be storing elements according to the index position, but the only difference is we will be storing elements that belong to the same data type. That is the only difference between arrays and list. And here to work with NumPy array, we will make use of this array concept over here. And if you consider this NumPy array, it is also called as the n-dimensional array or ND array. Actually, why we make use of this NumPy array in Python is it speeds up the data processing. That is the one main reason why we make use of NumPy arrays in Python. It supports very big data to handle the large data, data in large amount. We make use of this NumPy library. So not only for handling the large amount of data, but for analyzing the statistical related problems and to solve the scientific related problems. For all these things, this NumPy array will be very useful, and it can be easily interfaced with other Python packages also. So like the other programming languages like C or C++ also in along with other programming languages also it can be interfaced very easily. So this is one main advantage of making use of NumPy. And this NumPy array, if you consider it is a grid of values. Grid of values in the sense it supports the tabular data. That is, elements will be stored in the form of rows and columns, and we will be usually accessing the elements based on the index position. And the elements will be stored in a sequence with the help of the non-negative integers, much similar to the list concept. So how we store elements in the form of how we store elements based on the index position in list. So much similar to that, even in NumPy array, we will be storing elements based on the index position and we will be accessing based on the index position only. And rank of the array is nothing but the number of elements which you have in an array. So I'll show you an example so that you will be able to understand very easily. So the number of elements which you can store in an array represents the dimension, which is nothing but the rank of the array, and the shape of the array depends upon the list of integers giving the size of the array. So let us see how it works. And the types of NumPy arrays, if you consider, you have totally three different types. So one is a one-dimensional array, two-dimensional array, and then three-dimensional, which is also called as a multi-dimensional array. So one-dimensional array will store elements in only one particular direction, that is only in the horizontal subset. We will be able to store the elements in one-dimensional array. Whereas in a two-dimensional array, you can store elements in the form of rows and columns, which is also possible in a three-dimensional array. So these are the different types of NumPy arrays we have. In general, let us discuss what is meant by an array. So array, if you consider, it acts like a container. And we have discussed about the variable. Do you remember? So a variable acts like a container, I have told you, right? To store elements temporarily until we process it. Similar to that, array, if you consider, it acts like a container and it helps you to hold a fixed number of elements. That is, you can store only the minimal number of elements. That too, you have to specify the size when you are declaring the array. So when we declare the array, we have to specify the size of the array, like how many elements we are going to store inside the array. That represents a fixed number of elements. Clear? And all the elements which you are going to store inside the array should belong to the same data type. Whereas in list, if you consider, the elements can be stored the elements can be of different data types. It supports different elements of different data types. Like you can store strings, numbers, And the floating point numbers also you can store in a list in a single place, but it is not possible in your array. You have to store elements that belong to the same data type, and all the elements which you are storing in the array will be stored in the memory location one after the other. So it will be sequenced in an order. So that makes our work much easy when we are accessing the elements, and it helps in faster data processing. So that is the reason why this NumPy array makes use of the concept of arrays. And the and an array, if you consider, it consists of the element and index. So element is nothing but the item which you store inside the array, which is called as an element. For example, if I'm going to give the item as 5 or 6 or 7, which is nothing but an element. Each and every number which I'm going to store is represented as an item or an element, whereas in which particular position I'm going to store, that represents the index position. So this one we have already discussed in the list concept, right? So if you look at this example, you will be able to understand. See here, this is how the arrays will be represented usually, and int represents the data type, and according to the languages, different languages, it will differ. The declaration of array will be different. So int is the data type, and array is the name of the array. We can give any name with that we wish, right? And here the 10 represents 10 within the subscript represents the number of elements, that is the size of the array. That is, you can store only 10 elements for the array, for the name array. Clear? So here they have given the elements, they have assigned the elements to this particular array variable. Clear? So 35, 33, 42, all these are elements. And the elements which you have assigned to the array variable will be stored in the memory location like this. So for 35 takes the index position 0, always your index position starts with 0. It takes the index position 0, whereas 33 takes 1, so it will go in a sequence, right, with non-negative integers. And when we are accessing the elements, we will be accessing the elements based on the index position. And if I give int array of 5 means 19 will be accessed. So this is how we will be accessing the elements. So much similar to the list concept. And now NumPy array. So NumPy array, let us look at some of the differences between list and array, the general differences between the list and array, and how this NumPy array works. All these things we will be discussing now. It actually used to store the list of numerical data. So to work with numerical related stuffs, we make use of this NumPy array I have told you, right? And it supports vectors and matrices. So vectors in the sense, when you work with a one-dimensional array, it is called as a vector. And when you work with a multi-dimensional or a two-dimensional array, it is called as a matrices. Yes, and this NumPy library in Python, it has a large number of built-in functions. So which is all these built-in functions helps you to create, manipulate, and transform the NumPy arrays. So when we start to work with the NumPy related programs, you will understand very clearly for what we make use of this NumPy arrays. And the NumPy arrays, if you consider, I have already told you, it is also called as the ND array, but commonly we will refer to it as an array. ND array, which is nothing but an n-dimensional array. So let us look at some of the differences between a list and an array. So list means, I have told you, it can have elements of different data types. The elements can be of different data types like C1, 3.4, hello is a string, and then special symbols also you can store as a string, whereas in array it is not possible. So if you are going to store the integer related elements, you have to store only the integer related elements, whereas if you're going to store the floating point related elements, you have to store the elements that belong to the floating point related elements. You should not mix and match. Clear? And in the list, if you consider, elements are not stored continuously in memory, whereas in array the elements are stored in the continuous memory location, whereas it helps in faster data processing. And in the list, if you consider, it will not support the element wise operations, in the sense addition, multiplication, all these things are not possible, whereas because elements belong to different data types, right? So addition of elements or subtraction of elements, all these element wise operations are not possible in a list, whereas in array element wise operations are possible, because all the elements which we are going to store will belong to the same data type. So that is the difference between list and array. And if you consider here, um, it takes up more space in memory. List, if you consider, it takes up more space and it is very less efficient, whereas in NumPy array it takes up very less memory space because for each and every element, all the elements we are going to store in one particular memory location, and each and every element will not take up different memory locations and all, right? Because all the elements will belong to the same data type. So that is the main reason. And list, if you consider, it is a part of core Python, whereas an array, which is a part of NumPy library, so which helps in faster data processing. Now, let us see how to work with NumPy array. So to work with NumPy array, the very first thing which we have to do here is we have to install the NumPy in Python software along with the Python software. So once we have successfully installed that, we have to import it in Python ideally. So it is required to be imported. To import that, we make use of a particular statement. This is the syntax to import NumPy from the Python library. Clear? So import NumPy as NP. So import is the statement which we use to access the particular library. NumPy is the library name, and then as NP. So this NP is the alias name for NumPy, which we can make use of it as a variable in the programs. And this NP is completely optional. If you're not going to give this NP, we have to use this NumPy everywhere in our program. So instead of using this, we are going to use it as a short form as NP. So that is the reason why we give an alias name over here. Clear? And now let us see, this NumPy can be divided into two types. One is one-dimensional array and the other one is a two-dimensional array. So one-dimensional array, if you consider, it is also called as a vector, right? And the number of subscript or the index position, that determines the dimensions of the array. So the number of subscript, in the sense, totally you have 5 elements over here. So 0 till 4, totally you have 5 elements that represents the dimension of the array. So totally you can have 5 subscripts. So the array of one dimension is also known as a one dimension array or 1D array, whereas a multi-dimensional arrays or ND arrays. So multi-dimensional arrays, in the sense, more than one dimension is always represented as a multi-dimensional arrays, and it is also called as an ND arrays, right? And this multi-dimensional arrays or two-dimensional arrays you can also refer to as matrices, whereas a one-dimensional array you will represent it as a vector, and a two-dimensional array you will call it as a matrices. And to initialize a two-dimensional array or to create work with a two-dimensional array, we will be passing a nested Python list to the array method. Even to work with a one-dimensional NumPy array or a two-dimensional NumPy array, we will be passing the list to the array method. So while seeing the example, I'll explain how to work on that so that we will be able to easily access the elements. And an array of two dimension or index or subscript is termed as a two-dimensional array. So this is how the two-dimensional array will be represented in the memory. So it will have rows and columns, and usually the subscripts will be represented like this: 0 for 0, 0 of 1, so which is row and then column. So first subscript usually represents the row and the second subscript represents the column. Clear? And this is how we will be representing the array in memory. And now let us see the array method, that is how to create a one-dimensional NumPy array and two-dimensional NumPy array. So to create a one-dimensional NumPy array, we have to just simply pass a Python list to the array method. So look at this example here. Import NumPy as NP. This is the syntax which we have to use to import the NumPy library over here, and only then we will be able to work with the NumPy array. And now what we are doing here is L1 is a variable, and this 2, 3, 4, 5, 6 is the elements, that is we have created a list. Yes, we have created a list for the L1 variable. And now what am I going to do? I'm going to pass this list to the array method, np.array, this parenthesis, this is the array method. And for this array method, I'm going to pass the list which I have created here. You can either pass this one dimension, this list like this, or even you can pass this variable L1 over here to the array method. So both you can make use of both the methods. And I have assigned that method to the variable array1. And if I print using the print statement, print of array1, see what is happening here: 2, 3, 4, 5, 6, that gets printed as such. Can you notice one major difference between this list and array? I have passed the list to the array method, and here it has been printed as an array. The main difference between array and list, if you consider, In a list, all the elements will be separated by commas, whereas in an array, the elements will not be separated by commas. That is the difference between a list and an array. Clear? And see here, this is the alternative method. So instead of passing the list to the array method like this, I can also pass the variable which I have which I have used for creating the list. So this L1 variable I can pass here in the array method. So two different methods you can use. And even if you make use of the print statement, the same output you will be getting. Yes, it doesn't make any difference. And as usual, I have told you there is the difference between the list and the array. So if it is a list, the elements will be separated by comma, whereas in an array, the elements will not be separated by comma. That is the difference between a list and an array. Clear? And now we have discussed how to create a one-dimensional array by passing a list to the array method. Now let us see how to create a one-dimensional array from a string. So it is also possible to create a one-dimensional array from a string. And if you see here, as usual, import statement, data is a variable, np.fromString is a method, and inside this method, see what are the parameters that I have given. So 1, 2, 10 and 12. So these values I have passed here, I have given within this method as a string. I have passed as a string, followed by that dtype equal to int I have given, which is a dtype is a parameter and separator is a parameter which I have given for this method from string, which I have used for in this method from string. So data type I have given as int and separator I have given as space. I have not provided any comma. So this represents the space between the quotes I have given. I have given an empty quotes, which means the space will be provided between these elements. So if you print this particular variable, what happens here is the string will be printed as an array, right? So the string will be, now that is what np dot from string. So this from string has been converted into an integer. The string has been converted into an integer with spaces and it has been printed as an array. So this is how you can create a one-dimensional array from the string even. And now let us see how to create a two-dimensional array. So two-dimensional array, if you consider, the difference between a one-dimensional and two-dimensional array is when you're creating a one-dimensional array, you will be just passing only a single list to the array method. Whereas to create a two-dimensional array, you will be passing multiple lists to the array method. Multiple list or nested Python list. So see here one more list. Here, this is the first list and this is the second list, which is called as a nested Python list, or you're passing multiple lists to the array method. Clear? So A is a variable and np dot array of two list I have passed over here in this array method, and when I use this print statement to print the list, what happens? It will be printed in the form of two-dimensional array, that is rows and columns. So totally how many elements I can store here in one particular array? So four elements. Totally I have two rows and four columns. Clear? This is how you will be creating a two-dimensional array. If it is a one-dimensional array, you will be just passing only a single list to the array method. Whereas in a two-dimensional array, we will be passing a multiple list to the array method. It is not that I have to pass only two lists. More than two lists also I can pass to the array method. So like this, we will be creating a two-dimensional array. Clear? And let us see a few more examples related to this. So if you see here, as I have told you, if it is going to be a one-dimensional array, first we will be specifying only the index position. And if it is a multi-dimensional array, we will be having rows and columns, right? So to work with NumPy arrays, it is highly important to understand the way the arrays are indexed. So based on that, we are going to discuss few examples now. And if you see here, again, they have created an array. They have created a NumPy array by passing only a single list, which means see 1, 2, 3, 4 is a single list which we have passed to the array method. And when you print this array, the single array gets printed. And if you see in this example, here they have passed two list to the array method, and while accessing the elements, see, we will be making use of the index position. Using the index position only, we will be accessing the elements that I have told you. And one common thing between an array and a list is we will be specifying the index position for array as well as the list. So if you consider here, as we are passing the list over here, this particular the first list index position is 0, and for the second list index position is 1, right? And internally again you will specify the index position for the elements. So 0, 1, 2 and 3. Similarly 0, 1, 2 and 3. Overall index position, if you consider, totally the index position is 0 and 1. And they have given 1 comma 3. So 1 comma 3 means in the first index position, third element I have to access. So third element is in the third index position you have to access 24. So the 24 will be the answer. Again, if I try to, you can also represent that in this particular form. So 1 of 3. So the same value will be retrieved. Clear? And now if I'm trying to print this variable a, what will happen? It will be printed in the form of array. Clear? And in NumPy arrays, you have three main attributes. One is type, shape, and then item size. So type, if you consider, it helps you to check I mean the type of the NumPy array. That is whether the element belongs to which data type. To check that, we make use of the type function. And the next attribute, shape. And the shape, it helps you to find out the dimensions of a NumPy array. It returns the dimensions, the number of elements which you can store inside the array, right? And item size, it actually returns the length of each element of array in bytes. Length of each element of array in bytes means in one row how many elements you can store in an array. That represents the item size. Clear? And a few more examples they have given. See here. Import numpy as np as usual to display two-dimensional array. So here they have passed multiple list to the array method, and they have assigned it to the variable b. And now if I give b dot shape, now I have used an attribute here. So if I give b dot shape, what will happen? It will return the dimensions of the numpy array. Dimensions is in the sense how many rows and how many columns you have in an array. That will be returned, I have told you. So how many rows and how many columns you have here? 3 rows and 3 columns. So 3 comma 3. 3 rows and 3 columns you have. That represents the shape attribute. And if I give print of b, the entire elements gets printed in the form of array. If I give b of 0 in the sense 0th index position or 0th index, all the elements belong to the 0th index will be retrieved. 1, 2, 3 gets printed. Can you see the difference here? And 0 of 0 in the sense in the 0th index, 0th element I have to access, which is 1, will be retrieved. Again, 1 of 0 means in the first index, 0th element, which is 4, will be retrieved. Again, 2 of 0, second index, 0th element, that is 7, will be retrieved. So 2 comma 2 means second index, second element, 0, 1 and 2. So 9 will be retrieved. So now you understood. This is how the elements will be retrieved in a two-dimensional array. Clear? And few more examples. So for array 1, they have created one array that is a one-dimensional array, and here again they have created a one-dimensional array. Uh, so if you see here in array 3, they have created a multi-dimensional array, right? That is, they have passed multiple list. So if you print array 3, what will happen? It will print the values in the form of array. And now array1 dot ndim, which is it helps you to find the dimensions of the array. So for array1, what is the dimension? Only one. Yes, only one set of rows or only one dimension you have. That is what there has been retrieved as one. And array3 dot ndim, if you consider, it has two dimensions, right? So sorry, array3 dot ndim. So here you have two dimensions that will be displayed here. And as usual, size of the array. So it helps you to retrieve the number of elements which you can store in the array. In array 1, you have 3 elements, so that 3 will be retrieved here. In array 3, totally you have 6 elements, so that 6 will be retrieved. So all the other attributes works in the similar way. And now let us see some difference between NumPy array and list. So in the previous slides we have discussed the difference between list and array. And now we are going to discuss about NumPy array and list. So NumPy array, if you consider, it works on the same elements that belong to the same data type, whereas list, it made up of elements of different data types. And NumPy array, if you consider, it does not support the addition and removal of elements, right? So addition and removal of elements will not be supported in NumPy array, whereas in list the addition and removal of elements is possible because each an element belong to different data types, and it is possible to retrieve a single element or we can remove a single element So it is possible. And as usual, it can't contain elements of different types in numpy arrays, whereas it contain elements of different types. It consumes less memory, it consumes more memory, and it helps in faster runtime execution, whereas the runtime execution is very slow when compared to the array. So this is the major difference between the numpy array and list. And in the next class, we will be discussing about the methods to create numpy arrays. And I hope you understood till the concepts whatever I have explained in today's class. Thank you.